So the first skill that we're going to learn is something called orbital notation. And this is a model of the electrons in the atom that shows every orbital and what electrons are in it. So we represent an orbital with a line, just a simple line. And then we know that each orbital can hold 2 electrons, so we represent the electrons with up and down arrows. So what I have drawn right here, and I'm circling in yellow, that represents one orbital with 1 electron in it. To put in a second electron, I would draw a down arrow. Now, like I said earlier, we often do lazy arrows, and so you can draw a little half arrow, and that means the same thing. So let's take a look at this example right here. I want us to be able to determine what element this is, and there's 2 different ways we can do that. One way is we could count the total electrons. So I'm going to just count the electrons as I go across. 1, 2, 3, 4, 5, 6, 7, 8. So this is an element with 8 electrons. So check your periodic table. What element has 8 electrons? Oh, the numbers on this periodic table are a little bit weird, but on a normal periodic table, oxygen has 8 electrons. So this element here represented is oxygen. This is called the orbital notation, the blanks and arrows. Now, the other way that we could figure out what element it is by only looking at the upper energy sublevel. So I'm going to circle that in pink. The highest energy sublevel is 2p. And count the electrons in 2p. 1, 2, 3, 4. So we've got 2p with 4 electrons in it. So we're going to go to the 2p segment of the periodic table, and we're going to count to the 4th electron in the 2p level. So I'm going to highlight that in this purple. So element 1, 2, 3, 4. So oxygen is the 4th element in 2p. And so again, that tells us that the element is oxygen. All right. What we have here are 2 samples of electron or orbital notations. The first one here is sodium. Again, we know that it's sodium because if you count the electrons, there are 11 electrons. If we needed to draw this from scratch, and this is very important, so I'm going to draw over the arrows so we can see how we would draw this from scratch. And I'm going to do the same thing for the carbon one below. So follow along very closely. Sodium, I know by looking at the periodic table, I want you to look at it and find sodium. Sodium has 11 total electrons. So I need to fill in 11 arrows here to represent those 11 electrons. So my first level that I'm going to occupy is 1s. 1s is just a single orbital, so I can put 2 electrons in it. My next level that I can occupy is 2s, and I can put 2 electrons in it. Moving on, my next sublevel is 2p. Now, according to Hund's rule, remember that we do the up arrows first in a level that has more than 1 orbital. So watch and follow along and copy down what I do here. I'm going to put up arrow, up arrow, up arrow in my 3 orbitals for 2p. And then I'm going to do my down arrows. Down arrow, down arrow, down arrow. All right. Counting up my electrons, if you count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 11 electrons. I need 1 more. So I'm going to put 1 more in the 3s level. So I have 11 electrons. That means that is sodium. Next up, I have carbon. I want you to find carbon on your periodic table. Point at it. And it has a total of 6 electrons. So I am going to fill in my electrons from low level to high level. So I begin at 1s, up, down. 2 electrons total. Moving on, 2s, up, down. 2 more electrons, we're up to 4 total. I need 6 electrons, so I need 2 more. Now this is where Hund's rule becomes very important. I am going to do an up arrow in a 2p orbital and another up arrow in another 2p orbital. Remember that the 2p sublevel has all 3 of these orbitals available. That's like 3 bunk beds that we need to put 2 electrons in. They're not going to share, and so they're going to go into 2 separate orbitals. All right, moving on, we are going to practice with the element chlorine and arsenic, but what's different about these is it's not structured for you. We don't already have the orbitals listed. So first up, we're going to go to the periodic table and find our element. Chlorine is right here, circled in pink. It's in the 3p sublevel, and in the 3p sublevel, I'm going to mark with red that it's element 1, 2, 3, 4, 5. It's the 5th element in the 3p sublevel. So I need to go from 1s all the way until I get to 3p, and then I need 5 electrons in the 3p level. So follow along and write this down. Remember, if I'm writing it, you're writing it. So chlorine is going to start with the 1s sublevel with an up arrow and a down arrow. That represents 2 electrons. Moving on, I have the 2s sublevel, and I'm going to have an up arrow and a down arrow. Following on the periodic table that shows you the order of the sublevels, 2p is next. And a p sublevel has 3 orbitals. So you can just draw the 3 blanks with the 2p in the middle. I need to fill it completely and keep moving. So I'm going to fill up, 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 and down, down, down. I only have a total of 10 electrons so far. And we remember that chlorine has 17 total, so we need to keep going. My next level, so I've made it all the way through the 2nd row of the periodic table. I'm on the 3rd row now here, with which is labeled 3s. Just covered it up, 3s. So next up is the blank and 3s, and it's going to be an up arrow and a down arrow. And following the periodic table, the next level is 2p. And that is going to be 5 electrons. Please remember that you fill them up, 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 and down, down. Okay. Oh, and Miss Hammer, you made a big mistake. I wrote 2p down there. It's 3p. Oops. So I'm going to label that 3p. All right. We're going to do one more element in this method. We are going to do the element arsenic. So I'm going to erase some of the notations I had on here. I'm going to box the element arsenic. So this one is going to take a little bit longer, but that's okay. We need to practice going through the 4th row of the periodic table because that travels through 3D, and that is just a slightly different scenario. It's got a different number of orbitals, so we're going to start the same way. So here we go. Arsenic is going to start with 1s, fill it with an up and a down. Next is always going to be 2s, fill it with an up and a down. Next is going to be 2p, which can hold 6 total electrons, so that's going to be up, 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 down, down, down. Next is 3s. We're going to fill in the 3rd row now, just like we did for chlorine, but we're going to finish it and keep going because arsenic is on the 4th row. So 3s is filled, then we get to 3p. Fill it up, 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 and down, down, down. All right, we are now on the 4th row of the periodic table. So let's kind of get a plan for what it's going to be. It's going to be 4s, then 3d, then 4p. But on 4p, arsenic is only the 1, 2, 3, 3rd element. So we're going to end with 4p, but with only 3 electrons in it. So here we go. 4s is going to be 2. 3d is going to be 10 electrons. And then 4p is going to be 3. All right, so here we go. 4s is 2 electrons up, down. A D sublevel, like we have next, 3D, is 5 orbitals. So you can just put the 3D in the middle one, that's fine. I'm going to zoom in a little bit so you can see. Now I'm going to fill them up, 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 and down, 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 down. Oops. All right, the final row, or the final sublevel, is 4p. But arsenic is only the third element over. Remember, we counted that it's the third element in 4p. So I need 3 electrons. That's going to be up, up, and up. And that's it. All right. So those are your 2 examples for orbital notation. We are going to move on. If you need to see more examples of orbital notation, remember at the beginning of the slide deck, and you can get this on my slides on the HyperDoc. It's a video about orbital notation here, and you can get more examples to fill in. Same thing later for electron configuration or shorthand. All right, so moving on, that was the first version of electron configuration. We're now going to learn the second skill. The second skill is called electron configuration. So electron configuration is going to give the same information, but it's going to be written more concisely, and it's more commonly used. We are going to still show with a coefficient and a letter the sublevel. So that might be like 2s or 3p, etc. But then we are going to use a superscript to show the number of electrons in that level. So instead of blanks and arrows, we are going to show a simple number to show how many electrons are in that level. So I want you to study this example with me real quick. Don't write, don't do anything else, just look at this. We've got the element sulfur written both ways. The first way, above the line, is what's called orbital notation. But those blanks and arrows take a lot of room. So we're going to simplify. So I'm going to take that 1s with 2 arrows, and I'm going to write it as 1s2. So again, it's simply more concise. Next, I'm going to take the 2s that I'm highlighting in yellow that has 2 electrons and concisely write it as 2s2. That means the 2s sublevel with 2 electrons. Next, I'm going to take the 2p sublevel that I'm highlighting in blue, and I'm going to write it as 2p6 because it had 6 arrows, that's 6 electrons. Next, I'm going to take the 3s level that I'm highlighting in purple and write it as 3s2 because it had 2 electrons. I'm going to write a 2 superscript to show that it contains 2 electrons. And finally, the last sublevel occupied in sulfur is 3p, but it's not full. It only has 4 electrons. So I will write that as 3p4. So the top notation that I wrote here is called orbital notation. The bottom version is called electron configuration. It's got like the official sounding name, electron configuration. It is the most common. So the good news is you still predict the levels based on the periodic table. So if you think about the sulfur that we just encountered, we started with 1s, and it was 2 elements across, so 1s2. Then we went to 2s, and it was 2 elements across, so it was 2s2. Then we came to 2p, and it's 1, 2, 3, 4, 5, 6 elements across, so 2p6. Then we came to 3s, it's 2 elements across, 1, 2. And finally we got to 3p. But sulfur is not the last element, it's the 4th element. So because sulfur is the 4th element in 3p, we label it as 3p4. All right, let's do a couple examples. Sodium and carbon, which we did earlier in class or in the video, are written here. So those are translated for you. We're going to do some examples that I just pick. So my first one that I'm going to pick is the element calcium. So we're going to locate calcium on the periodic table. and it is right here. So it's in the 4s sublevel, and it's the second element. So we're going to end with 4s2. But we have to get through everything to get there. So I've circled all the sublevels that will be occupied for calcium. And then we're going to include the little exponent or superscript number to say how many elements across it was, which is how many electrons are in that level. So here we go. For calcium, we're going to begin with 1s2. Moving on, 2s2. Moving on, 2p6. Moving on, 3s2. Moving across, 3p6. And finally, we got to our element location, which is 4s2. All right. For my next example, I'm going to pick an element that's a little bit farther down. I am going to pick the element silver. I want us to practice going through the D block because that is common. That's the yellow area here. So to get all the way to silver, follow along on this periodic table. Just watch for a second. I'm going to start with 1s, and it's 2 across, so that's going to be 1s2. Next, 2s2. Next, 2p, 1, 2, 3, 4, 5, 6 across. Okay? So let me fill this in down here. So what have we done so far? For the element silver, 1s2, 2s2, 2p6. Let's continue on to the third row of the periodic table. That would be 3s2 and 3p6. Next is the fourth row of the periodic table. I'm going to circle on the periodic table what we got. We got 4s, which is 2 across. So that's 4s2. Back to the periodic table. 3d is 10 elements across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 3d10. Next up, 4p is 6 across. So 4p6. Now we're on the final row where our element silver is. So I've got 5s with 2 across, so 5s2. And finally, 4d, but we don't want to go all the way across to 10 because silver is not the 10th element. So in the 4d level, I'm going to highlight or mark them in pink. A silver is number 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4d 9 is going to get us to silver. So that is how our answer is going to end, 4d 9. All right, I'm not going to ask you to do many elements that are as big as silver or bigger because, yes, those are very long answers. We are going to learn a shortcut method. But first, what I'd like you to do is go to Schoology. This is if you're in class, and look for the assignment called Electron Configuration Self-Checking Practice. It says in the Unit 3 folder, but you are not going to find that if you're doing this in class. You're going to find it in the folder for the day. So I want you to find the assignment called Electron Configuration Self-Checking Practice, and I want you to get 4 correct. So you're going to type in the sub-levels. So you're going to type in a 1 in the first box, and then an S in the second box. And in the next box over, when you type a 2, it'll make it a little upper number. In this assignment, it turns neon green if you got it right. So head on over there. There's some instructions and play with it. And I need you to get 4 elements correct and hit submit before you continue. And then come back to the video because there is one more thing in the notes that we need to talk about. Continuing on, we are going to look at what's called shorthand notation. So instead of writing the whole electron configuration notation, which is very long sometimes, we are going to do the symbol for the last element in the previous row, which is going to be a noble gas, It's going to be written in brackets to represent all the electrons up until that row, and then we will continue. So for instance, the element sodium, which we've been looking at today, let's find it on the periodic table and follow along. You don't need to write anything, just follow along. Here's the element sodium. To do shorthand notation, follow my pointer. I'm going to go to my element sodium, go to the row above it, and go to the end of the row. The noble gas out here is neon. So I'm going to write neon in brackets, and that represents all the electrons up through the 2p level. And then I'm going to continue. So to get to sodium, I'm in the 3s level, and I need 1 electron. So this is what would be called shorthand notation for the element sodium. Again, follow my pointer. You go to your element, you go to the row above it, you get the noble gas that came at the end of that row, which is neon. That represents the first 10 electrons, and then you continue on with the row where your element is located as normal. Okay, we're going to do some class choice here. The first element that I'm going to pick for us to do together is the element chromium. So, where you have a space for class choice, let's write chromium. So, follow my pointer. Chromium is right here. I'm going to go to the row above it and go to the end. The noble gas out there is argon. So I'm going to put argon in brackets. And then I'm going to continue with the 4th row of the periodic table until I get to chromium. So I'm going to write argon in brackets and then continue with the 4th row of the periodic table. 4s2. And then chromium is in 3D, but it's not all the way at the end. So I'm only going to go 1, 2, 3, 4. So I'm going to write 3d4. That means in the 3d sublevel, I have 4 electrons. All right, let's do another example. Let's do the element iodine. So iodine is here in the 5th row of the periodic table in the 5p level. So to do shorthand notation for the element iodine, I'm going to put my finger on the element iodine, go to the row above it, and go to the noble gas at the end. It's krypton. So I'm going to put krypton in brackets. That was the end of the 4th row of the periodic table. So now I'm going to continue with the 5th row of the periodic table. So 5s2. 5s had 2 elements. 4d, remember, is 10 across. So 4d10. And finally, we get to the location of our element iodine. Iodine is in the 5p sublevel, and it's element number 1, 2, 3, 4, 5. So 5p5. All right, we are going to do one more element. We're going to keep it simple. I'm going to pick the element phosphorus. So phosphorus is in the 3p level. Let's find what noble gas we would begin with. Phosphorus is here. I go up a row and to the end. I've got the element neon. So I'm going to put neon in brackets and then continue on the 3rd row until I get to phosphorus. So neon in brackets, continue with the 3rd row. That's going to be 3s2, 3s2. And then moving on, I've got the 3p level where phosphorus is, but phosphorus is only the 1, 2, 3, 3rd element. So 3p3. So this is called shorthand notation. And you can only do shorthand notation when I say do shorthand notation. All right, the last thing that we're going to talk about is valence electrons. An atom's valence electrons can be determined by locating the electrons in the atom's highest occupied energy level. So if we look at the element yttrium and look at its electron configuration, we've got a 5 sublevel and we have a 4 sublevel. The highest energy level here is level 5. So how many electrons are in level 5? 2 electrons, so yttrium has 2 valence electrons. Let's do a couple more together. We're going to underline the valence electron levels. So looking at this first one here, we have a 1, a 2 sublevel, a 2 sublevel, a 3 sublevel, a 3 sublevel, and a 4 sublevel. The 4 sublevel is the valence level. How many electrons are in it? 1. So 1 valence electron. Let's look at the element below. We've got a 4, highlight. We have a 4 sublevel and a 6 sublevel. So which one is higher? The 6 sublevel is higher. How many electrons are in it? 2. So 2 valence electrons. Let's take a look at one where we have multiple sublevels that are the highest level. So looking at the next example, we have a 1 sublevel, a 2 sublevel, a 2 sublevel, a 3 sublevel, and a 3 sublevel. Which one is highest? The 3 is the highest. So all of the 3 sublevels count as the valence level. How many electrons are in them? 2 plus 5, 7 valence electrons. All right. We are going to end there. Your homework is number 303 on formative. If you are in somebody else's class, or if it's not 2023, that might be different. But for this year, it is number 303 and it's due next class. Thanks for watching. Check my notes for more information. And remember that there are those helpful videos at the beginning of the slides if you need more examples.